Welcome back to Cloud Computing series. In this video, we'll be discussing the important questions or important topics to cover from third module. So third module is all about the cloud computing architecture. So if you have not watched my previous videos, I've tried covering all the important questions module wise. So do check that out because we have discussed all the questions there. And if you're new to my channel, do subscribe. I'll be uploading module wise videos for not just cloud computing subject, but all the CSIS related subjects. So let's get started. The first topic which we'll encounter is the cloud reference model or cloud computing model. If you see cloud reference model or cloud computing model, there's a for both of these there's only one figure, that is the cloud architecture, cloud computing architecture. Under this only we'll have the concepts of the cloud reference model and the architecture also defined here. So let's understand what cloud reference model is. So cloud reference model will tell us what are the multiple aspects present in the model. So it is a prototype which is designed. It is the structured definition of how the cloud is being assigned in the network. So it has the infrastructure, what are the services it offers, how does the development platforms, what are the development platforms, what are the applications, all those things are specified in this model. Then this model will support various IT services and it can be consumed as utilities. We know what utilities are. So like gas, water. So we are paying for all these and using it as per our convenience, right? So we are paying as much as we need and then we are using it. So similarly, even cloud is considered as utility and they are delivered through internet. So we access the cloud and perform various operations on cloud through internet. So by considering this model, it will support various IT services which can be used as utilities and then delivered through internet. So this was about the cloud reference model. Now we have the cloud architecture. They've specified what architecture is. Okay, so cloud architecture tells us that how the hardware, middleware, software are arranged. So all these are structured into a stack kind of a thing. So multiple aspects are arranged in layered architecture. So that's what they have told here. So starting from down, we have at bottom most we have the physical infrastructure. Then moving upwards, implementation wise, the cloud elements are structured over the stack. Hardware first, then middleware, then software. So this stack provides a scalable computing power. So speaking from the computational aspect, it provides a good computation power, typically through data centers where multiple nodes will work together. We know what data centers are. Data centers are those physical centers which are spread across the world. So in data centers, will have all the servers or the physical infrastructure which is required to perform or to store the cloud data, to store our data in real. Okay, so the bottommost layer is the infrastructure management and the topmost layer is application delivery layer. So both of these will cover different aspects of cloud services. So first we have is the physical infrastructure. Physical infrastructure lays the foundation of cloud computing. So hardwares like server, storage, network resources are all considered under the physical layer, infrastructure layer. Then we make use of clusters here. Network PCs are there. So if you can see here, clusters are there, network PCs are there, database systems are there. So these are all used to store the data, maintain the data, manage the data. It's all in real. Physically, those equipments are present there. So they'll handle all the heterogeneous data here. So it, not just that, it also includes the management tools and the physical tools to provide support. So they have virtualization techniques which will allow this layer to be utilized. Of course, through virtualization only we'll be making use of these technologies, right? Then virtual machine will abstract the resources to create environment where applications can run independently and isolate from others. So this is just the basic definition of virtualization and how it actually works. Next we have the core middle layer. So the middle part, so it will manage the infrastructure and it will provide the runtime environment for applications. So here the development platforms here it is also, so here the development platforms are integrated here. So it ensures efficient resource allocation and it provides features like quality of service and virtualization management. Next we have platform as service. Platform as service provides the development platforms, provides tools, frameworks to build applications directly on top of the infrastructure, cloud infrastructure. So here we have the web interfaces, different command line tools, distributed programming framework is there, and many other things are there which we can run directly without worrying about the hardware here or the infrastructure here. Then we have software as service. Software as service, we know the topmost layer. Cloud applications are provided as services to the end users here. So web based, it is mostly software applications are accessed through the websites only, right? Via internet. So, and they rely on cloud to scale and manage large number of users. Examples could be the CRM software, email, Facebook, Twitter, and all of that. So, it is highly scalable, reliable, and efficient. Next, we have the adaptive management and autonomic behavior. Adaptive management and autonomic behavior. So, this will ensure that there is elasticity for the performance and availability. So, for for software as service, the automatic scaling, performance management, all these are the factors. Then we have the platform as service and the infrastructure as service. So here the exposed APIs will allow users to scale their services according to their needs. So this was about the adaptive management and autonomic behavior. Then we have the everything as service, XaaS. So here it will combine services from various providers and it will integrate solutions. It will form the virtual web frames, farms, and it will enable cost effective scaling for the startups or small companies and all. So these are all the points you have to write. And looking at this figure, it's pretty easy. And so here we have the system infrastructure. So system infrastructure will have all the physical components, virtual machines would be there. Here we have the database is there. Here CPU for storage purpose and all of that. Next we have the middle layer, so middleware. So it will manage the SLA compliance and quality of service negotiation, resource allocating the resources. All those things are happening here. Then monitor execution management, metering, accounting, all those things are happening here. Then next we have the user level middleware. So here there will be different APIs and environments like Web 2.0 mashup, concurrent, distributed programming, workflows, libraries, scripting. All those things are present here. Next, above that we have the cloud applications. In cloud applications, the end users, what will they use? The social computing, CDNs, scientific computing, all those things are present. So adaptive management, autonomic cloud economy are all supported in various levels of this architecture. So if you are trying to group this individually, so if you consider just this and this part, you can consider it as infrastructure as service. Next, if you are considering this entire thing, here you have the platform also being specified. So here it is pure platform as service, this part. And if you are considering this, it is pure software as service part. So this was about the first question. This question is pretty important from exam perspective. It will be definitely asked for 10 marks. So you need to draw the diagram and explain all these points properly. Moving forward, we have, so as I said, this topic has very minimal topics. So they can ask what is infrastructure and hardware as service for 5 marks. So there's a figure for this. We have to explain the figure. And yeah, so the first topic, this is very easy again. So infrastructure as service represents a very mature and popular segment in the cloud computing because it has all the infrastructure in it, right? So be it the network, uh, networking devices, or the storage devices, web servers, load balancers, all those things are present inside the infrastructure. So it provides a backbone in hardware virtualization. It will enable creation of virtual machines which are tailored depending on our need. So virtualization is built upon the infrastructure as service, right? So it provides services to both providers and customers or consumers. So it allows customization of virtual infrastructure with selected operating systems and applications. So depending on the operating systems and applications, you can further modify or customize it according to your need, right? So it provides a foundational layer where virtualized hardware resources are provided. We know this. It delivers virtual machine storage, networking that can be optimized as we have seen in this step. So there are virtual servers here which will emulate the physical hardware and it will run on the custom software. So speaking of the types of storage here, either it could be the virtual storage, that is the virtual machine part, or the object storage that is actually stored in the database or the servers here. Examples here are the Amazon EC2, Amazon S3, Google Cloud Engine, vCloud, and other things. So virtual networking services are used to connect the virtual machines to the outside world, that is internet, and also for managing the security, access, and scaling up of the network. So here for infrastructure and hardware, they are basically they are discussing about the virtual machines and what are the services being provided. So we know virtual machines are very important and they run on pay as you use model, right? So in second module, we have covered all the topics related to virtualization. If you have not watched that, do check that out. And yeah, so the core component of infrastructure as service is the virtual machines. So to enhance the functionality, we have additional features like the SLA based resource allocation, workload management, integration with third party infrastructure as service solutions. We have user interfaces. So user interfaces, we have different web services. There would be the RESTful APIs, management consoles, customization support, programmatic interaction is provided here. So in this part, right. Next, we have the infrastructure management software where we have pricing, billing, monitoring, reservation, QoS, quality of service, SLA management. All those things are the different functions which could be performed, different softwares which are present here. So that is considered here. So like pricing and billing means like it'll keep a track of the how much users are using what, how much data users are using, and again calculating it accordingly, maintaining a log of when they log in, when they log out. Reservation is managing the virtual machine deployment, when it has to deploy and all of that. Quality of service and SLA management means it will ensure execution meets the quality standards. And then we have provisioning, which will provide the services properly and all of that. Next, coming to physical layer. Physical layer is the bottommost layer, which will consist of the physical resources. Like there are data centers here, clusters here, different PCs. PC, it could be at my home, or heterogeneous environments are there. It will also have the virtual resources which are provided from the third party. So this layer is the foundation, and it is the core part of infrastructure as service. Next, we have complete versus partial IaaS solution. Complete infrastructure as service means it will include all three layers. That is, user interface would be there. So that is, user interface would be there. Then it will have the software, and then it will have the physical infrastructure. Providers like EC2 and all, they are the complete IaaS solutions. Whereas coming to partial, like they'll rely on the third party here, third party infrastructure for physical resources. But then they'll again they'll have all this, but then they'll rely on the third party cloud. So again they'll offer user interface and management layers. So we can sum up that the infrastructure as service could be used for computing and storing purposes. So this is very important for any cloud platform to host, any cloud software to run. You definitely need the infrastructure. And if you are planning to set up your own company, instead of purchasing the infrastructure, you can go up for IaaS services. So this was about infrastructure as service. This will be asked for 5 marks. There's nothing much to explain. I've just elaborated whatever is present in this figure. Next we have is platform as service. Platform as service is the middle layer which is built on infrastructure as service, IaaS, and it provides scalable and elastic runtime environment where developers can deploy and run their applications very efficiently. So here we need not worry about the infrastructure. We can just move on to developing the applications here. So we can focus on writing the code while the platform will handle the scalability, availability, and fault tolerance. So speaking of the PaaS services, scalability, availability, and fault tolerance are the three main aspects. So this platform as service will provide the necessary tools, what are the softwares and frameworks to manage our platform. So again, it is very customizable. So whatever I want, I can customize it accordingly and run or manage my platform. So cloud provider is responsible for giving us the platform. So the major cloud providers here are the Google App Engine, Windows Azure, and Hadoop. So this was about the platform as service. Looking at the key features, first one we have is web-based interfaces and APIs. So developers can make use of the web-based APIs and interfaces. Like here we have web services, portals, REST API. All these things could be used. And then we have elasticity and scaling. So the platform can adjust automatically. So suppose if there is high demand, it will adjust. So if there is high demand, then it has to be like fault tolerant or load tolerant should be there, right? So suppose the VTU application which we are accessing, if there is high demand on the result day, the application should be, or the platform should be capable of managing all the load. So that doesn't happen on the VTU website. But then speaking from this platform as service perspective, it is available or it could be ensured here. Then we have application and resource management. So the core middleware here will manage the application deployment, load balancing, resource allocation, and all of that, right? So all the resources are managed here properly. Then we have quality of service and SLA management. So this will make sure that services meet the predefined standards or the quality QoS service. So quality development models. So platform as service will offer development models depending on which platform they are running. So one we have is web-based interface. So in web-based interface, it is completely cloud-based interfaces for designing, prototyping, deploying applications. All these things could be done by using the visual programming or rapid prototyping tools. Next one we have is the programming languages. So some platforms may have flexible approach. So developers can make use of the languages, popular languages like Java, Ruby, .NET and all. So moreover, this will provide a flexible approach, and in terms of scalability and security, it is very efficient enough. Next, we have the types of services which are provided here. So the platform as service solutions could be categorized into PaaS 1, 2 and 3. 1 means it will offer complete web hosted development environment. So it will have the middleware as well as the hardware. It is complete package. For example, force.com. Next, for PaaS2, it will only focus on scaling the web applications like Google App Engine or any other. So it will provide the runtime environment for specific languages. It could be Java, Python, Ruby, and all of that. Then we have PaaS3. So here it will provide more comprehensive cloud programming model. So this kind of model is provided in the third category. Okay, so it is not just limited to web. It is also limited. It also exceeds to the programming languages. Example here is the Microsoft Azure. Now look into this figure, the platform as service reference model. So here we have all the key components specified, right? So we have to just mention all these key components and what do they do. Just 1-2 lines of explanation would be fine enough. We have web-based interface, so it will have like a portal or a dashboard where the end user can interact. I can interact with the platform here. Then we have the core middleware here. So core middleware will manage the runtime environment. So it'll have application management, QoS, SLA management, user management, resource management, elasticity and scaling. All of that is present here. Then we have programming APIs and libraries. So these are the tools which are used by developers to develop the applications, integrate applications, build applications, all of that. At the end, we have the physical infrastructure. So physical infrastructure will have all the infrastructure which is used to support the platform as service. So depending on the as a foundation of this platform as service will run, right? Yeah, that's it. So here we have the IaaS, infrastructure as service. These are the cloud providers. Okay, so this was about platform as service. Moving on, we have software as service. Software as service is again very easy. So it is the top layer. It is ready to use on-demand software applications through internet could be accessed, which are hosted and managed by the service provider, and they're accessible through a web browser. So they include common business or consumer applications like email, doc or CRM management, photo editing, Facebook, Twitter, and all of that. Then they are scalable. That is, multiple thousands of people can access the Twitter accounts, right, at once, and each and every person will have their own authority to their own account present in this Twitter cloud, right? So it has highest level of abstraction. So if you are accessing a software, you won't get to know what is the platform built, and you won't also get to know what is the infrastructure behind it. All this is abstracted. Examples are the Google Documents, Microsoft Office 365, Flickr, and so on. So here we have the key features. First key feature is accessing through web. So we know that software as service applications can be accessed through web. They need not be installed in our systems. Okay, then we have no maintenance because we are not having the hardware here. We are not having the hardware present here. We need not worry about the software updates, security patches, maintenance, and all of that. Then we have pay-per-use model, that is how much whatever you want, whatever features you want, you'll pay for it and you'll get the features there. So that was about the pay-per-use. Then we have software as service 2.0 evolution. So here it is a newer evolution of the software as service model. So it will focus on integration with the other services. It will allow the third party applications to run. It is creating a more customizable, scalable system. So this will help us to shift into a more business centric approach where everyone can connect different services and components to meet whatever their business needs are. So popular for business applications, CRM, ERP, office tools, skill, social media, networking platforms, all these are examples where the software as service 2.0 is used. Next, third question, the important question which we have is types of clouds. So they can ask types of clouds for 10 marks. It is very simple. There are no it's not that difficult to write this, right? So all these are general topics. Even if you don't know, just remember 5 or 6 features. You can keep on elaborating it, explaining it, and that's how you can fetch marks. So we have public clouds. Public clouds are the most common and widely known clouds in the cloud computing. So they are distributed systems often built across multiple data centers which are interconnected and serve as backbone for cloud services which are offered. So they are available to anyone who subscribes to the service. Anyone can access these clouds, provided that they have to pay for that. So they can sign in with the credentials, enter the payment details, and then they can start using the cloud services. For example, the Google Drive is a public cloud, right? You're paying it and you're using it. Then it is scalable. That is, it can handle large amount of data. It can handle large amount of data. So initially it is 15 GB is free for everyone, and if you pay some amount, it can go up to 1 TB, right? Then they have a global reach. That is, anyone can access it from anywhere, right? Then cost efficiency. Of course, you are not investing physical hardware, physical servers to store your data, right? So you are just making use of the public clouds. Thereby, it is cost efficiency. And then we have the management and accountability. So yes, it is like it provides in like it'll provide us the software infrastructure to maintain the resources, manage performance, and ensure quality of services met. So it'll also track the usage and billing, ensuring the transparent and accurate service delivery is happening. At this point, the infrastructure is shared. Infrastructure is shared means multiple people are using Google Drive at same time, right? So provided in this data center, your data would be stored here, your friend's data would be stored here, and accordingly. But all these data is being accessed at same time. So it is multi-tenancy. So these are all the key features about public cloud. So yeah, it is very easy. Next, we have the private cloud. So private cloud are like it is a slightly above version of the public cloud. So this is made for specific organization or institution offering a controlled environment where the IT infrastructure is provisioned within the company's premises. So if you have issues related to your security, compliance, control, then you can go up with the private cloud here. So these clouds are address concerns with security, compliance, control. Yeah, I've covered this. Looking at the key features, first one we have is security and control. So private clouds will provide proper security that will help us to save or secure the sensitive data, critical systems in-house because of the security, compliance, and regulatory concerns. For example, the military data, all that has to be stored in the private cloud. It cannot be stored in the public cloud because anyone can access it, and to avoid any such risk, we can go with the private cloud. Then we have customization. Like in public cloud, it is fixed, only 15 GB free. But or if you pay, you get 1 TB free. What if I want just something intermediate? That is not customizable, but here it is customizable depending on how much you want. As you pay, you get your services allotted here. So thereby, the proper resource allocation is happening. You're paying depending on the model or the whatever services which you choose. Then you have in-house infrastructure and cost efficiency. Of course, so private cloud will depend on organizations' existing infrastructure. It could include the data centers, clusters, desktops, all of that. So thereby, the need for capital investment and the optimized usage of current resources is happening here, thereby saving money also. Then we have compliance and SLAs. So private cloud will provide organizations the strict rules which they have to follow, and along with that, service level agreements are also there. So for providing strong security, and if any disaster is happening, how to tackle that disaster, all those things are present here. But then one disadvantage here is it has limited scalability. Comparing to the public cloud, private cloud will have limited scalability because they are relying on my company's software, my company's hardware, sorry, my company's infrastructure. They can scale within the organization using their own resources, but then they don't have the ability to like uh, elastic nature is not present as compared to the public clouds here. Here if you look at the figure, it's private cloud hardware on and software stack. So first we have is the physical hardware where all the data centers, clusters, desktop grids are present. These are there in the company's organization. Next we have the virtual machine technology. So the foundation technologies for virtualization, it could be the Zen technology, VMware, KVM, all of that. Next, we have the infrastructure management software. So this will have all the management tools like VMware, vCloud, and all of that. So this will manage the infrastructure and provide the infrastructure as service. Next, we have the PaaS solutions here. So they provide higher level services, and they have the data synapse, Zimori pools, Elastra Cloud Server, Anika, and all these things are the platforms which are providing services. So they'll support the deployment of distributed applications and combining with the complex cloud environments. So this was about private cloud. Next we have is the hybrid cloud. Hybrid cloud is combination of both private and public. So they'll help us to maintain control over the sensitive data while leveraging or making use of the scalability and flexibility of cloud resources whenever they are needed. So like they provide a solution that addresses the limitations of private clouds. So in private clouds, they cannot be scaled and they cannot handle the peak loads. So thereby, you can go with the hybrid clouds. Looking at the key characteristics, first one is integration of private and public cloud. So hybrid cloud means it is combination of both. So here they'll integrate additional resources from one or more public clouds and then come up with a hybrid cloud. Next we have is dynamic provisioning. So dynamic provisioning and cloud bursting. So dynamic provisioning means you have the ability to scale on demand. So this can be achieved like when people are using our application on a very regular basis, demand would be more, thereby you can scale it. And when it is not being used, you can cut down the requirement of your resources, right? So that is happening here. So the practice like temporarily release when the private cloud's capacity will exceed can be done here. So that is called as cloud bursting. So by doing this, we can ensure that the cost efficiency is maintained. Then we have security and control. So security and control can be achieved. So by making use of the private cloud, you can store the sensitive data and critical data there. And in public cloud, you can generally store whatever is not that time critical or sensitive data. And we have optimized use of resources. Again, as I told, whenever I want, I'll access. Whenever I don't want, I will not access. And even when there is high demand, also I'm able to use it properly. All such things could be achieved by making use of hybrid clouds. Next, we have is the cost management and scheduling. So, cost management and scheduling is like a proper cost management is happening. How much resources you are accessing and how much data or how much storage you are accessing. All that is properly calculated and it is scheduled also accordingly. So, advanced scheduling like this platform is used to ensure that public cloud resources are used cost effectively by determining when and how to scale accordingly. Then we have platform as service solutions for hybrid clouds. That is by making use of platform as service like Aneka, we can enable the hybrid cloud setups are working properly. They'll allow the applications to scale dynamically across private and public clouds. So they'll include features like budget based resource allocation and meeting the standards, quality of service, and all of that. Here we have the figure. Yeah, here we have the use cases. So hybrid cloud can be used suitable for those companies which need a balance between the control and as well as the security with flexibility. Flexibility is main component here, right? Then it can be used for companies who require scalability during traffic. That is when peak times you need scalability, right? So in such conditions we can use this. And for those companies who maintain compliance and security for sensitive data, yeah, having the quality of service and compliance, strict rules and regulations would be there and everyone has to follow it, thereby you are providing stronger security. Here we have figure. So it is, if you see this figure, it is combination of private, public cloud. So it is all mixed. That's when we get the hybrid or heterogeneous cloud. So private cloud means the internal infrastructure of organization, data centers, clusters, all those things are there. Then in public cloud, it has external cloud services like Amazon EC2. Yeah, that is the one example which I remember. Then we have this dynamic provisioning. So the process of adding or releasing the public cloud resources depending on the demand which you are asking. So by making use of this, scalability is achieved. Then this entire thing will tell us how the distributed system is working when the private cloud will integrate resources from the public cloud to meet the demands, to meet your customer demand. So we have seen cloud bursting is happening here. Next we have is community cloud. Community cloud are the distributed systems which are designed to meet specific needs of a particular industry or a community or a business group by integrating resources from multiple organizations. So you're making use of multiple organizations, and there could be a business group which is related to only same domain, so those people can set up this community cloud. So they are used by a group who share similar concerns. So this cloud can be managed by a community member, or a third party can be used, or this third party could be present on site, or it could be off premises. Looking at the features, first one is we have shared infrastructure and collaboration. So community cloud are built on resources which are contributed by different organizations, different companies. So it could be the government bodies, private companies, public infrastructure providers, and all of that. So by making use of these, we are just whoever is having a common concern like security, compliance, operational needs, all those people can come together, collaborate, and then come up with this cloud. So if you see the public cloud, there is a broad user base. I might use public cloud to store my photos. You might use public cloud to store your documents. Other person might use public cloud to store his notes. But then my usage is just my aim is just storage. Your aim is suppose if you are storing bank documents, it is security plus storage, right? So here our concerns are differing. So thereby I cannot come up with community cloud there. In community cloud, all your aim should be same. Either it is security, compliance, or whatever the operational needs are there. Examples are the media industry. So media industry will have the digital content sharing and all of that, managing the large data and all of that. Then we have healthcare. Healthcare, again, the non-sensitive information could be shared here. Then energy and core industries, other core industries, public sectors, and it is used in the research and scientific computing. Then it is vector independence and openness. So community cloud will reduce the dependence on a single cloud provider, and because we are having multiple cloud providers, multiple people combined, it will have an open system. So by open system, there is fair competition between people. Suppose one person is asking a costly, very high rate, then I can leave that person and then move or consider the other cloud providers, and thereby there is fairness provided there, right? And community ownership is also there. Then benefits. First one is graceful failures. Graceful failures means with no single provider in charge, this community clouds are less vulnerable to single point failure. That is, system is distributed across multiple contributors, so there is less chances of failure. Then we have environmental stability. So these cloud platforms will have lower carbon footprint because they are making use of the underutilized resources, and they are growing depending on the community's needs. Then you have convenience and control. So they are pretty easy to use, and there is a standard control also, because all the people around present in that industry might be using the data only for a fixed limit, might be using the storage aspect for a fixed limit. Then we have scalability. So the infrastructure can scale largely depending on the user and whatever necessary requirements he has. So this was about the community cloud. Here we have figure. So again, so here we have the community cloud. So a cloud which is formed by integrating multiple clouds here. So you can see third party cloud, public cloud, private cloud, public cloud. All these are included. Private cloud means we know, public cloud means we know. And you are providing application services are there, infrastructure is there, development platforms are there. Yeah, this is pretty easy figure to understand. Next we have is economics of cloud computing. So the first topic is first let's discuss what economics of cloud computing are. So cloud computing fundamentally shifts the way of organizing from the IT infrastructure to the cloud. So by doing this, you should also speak from the money perspective, economic perspective. So the main thing here is pay per use or pay as you use model. So let's see what are the financial benefits in this. First one is cost reduction. Cost reduction, inside that we have capital cost. So if you are going with the normal technology, you have to set up the IT infrastructure, you have to purchase the software and all of that. So instead of going with that, even while you're setting up the software, you need to purchase the software, right? So in such cases, businesses can go up with the cloud computing, that is pay for the software on subscription basis and then use the software or use the resources accordingly. Then we have depreciation cost, that is the proper capital assets like hardware, software can depreciate over time. So in traditional models, this depreciation will affect the profit of business. So after a certain time, they need to buy a new processor, new system, and all of that. But then when you're talking about cloud computing, all that is not necessary. So you are saving the depreciation cost here. So it is eliminated because infrastructure is not needed here itself. Then we have operational and administrative cost. So the cost again to maintain the infrastructure, maintain the systems, maintain the servers. If you are having big servers in your company, you should have the coolers. So again, you are using electricity here, and regular maintenance should be there, and someone should be there to administer it continuously. All these costs could be cut down by making use of cloud computing. So capital cost, firstly, depreciation cost, and operational and administrative cost. So all these three costs could be cut down by making use of cloud computing. Next we have is the financial impact for different business sizes. If you are speaking from a startup perspective, money, the amount which they are investing is very less. So they have to make use of all the resources which they want. In such conditions, they can go up with the cloud computing because there are multiple benefits. Your cost reduction is there, your resource optimization is there, and green initiative is there. All the advantages of cloud computing could be written here. Then speaking of the established companies, so larger companies will have they have the capacity to set up their own infrastructure, but then again the depreciation cost will play an important role here. So instead of investing money on the resources which will lack their ability after a certain time, you can go up with the cloud computing, right? So you can eliminate that cost. So again, this is again a double benefit for the established companies. Firstly, they were making profits, they were having infrastructure. Again, to enhance whatever they are working to level up, they can go up with cloud computing. Next we have is the indirect cost cuttings. First one is software licensing. So if you are using the traditional method, you have to purchase the software and again pay a hefty amount. But then if you're using the cloud computing, you can go up with the subscription based models where I can pay only for what I need rather than the entire license. Then we have carbon footprint reduction. That is, I can help to reduce a company's carbon footprint by not using the IT infrastructure, but then coming up with the cloud computing or the cloud infrastructure. So thereby I am I'm lowering down the carbon footprint. Yeah, next we have is the cloud pricing model. So there are three types of models which we can make use of. First one is tiered pricing. So depending on fixed specifications and the service legal agreement SLA, you can come up with the tiered model here, tiered pricing here. For example, Amazon EC2 will use the tiered pricing where users will pay depending on the server configuration, like what is the CPU type they want, memory capacity, or on hourly basis. All that is done here. Next, we have per unit pricing. Per unit pricing means customers will pay for those resources or the specific resources which they are making use. It could be the data transfer, memory allocation, storage, and all of that. So this will have flexibility in configuring systems depending on actual needs, whatever are required. Then we have subscription based. Subscription based are depending on what are the software services which I need or the specific components which I need, I can pay accordingly and use them. Next we have is financial flexibility. That is, by making use of cloud computing, I can shift from the convert capital expenditure CAPEX to the operational expenditures OPEX. So instead of committing large amount of capital to buy new hardware, software, I can move up. I can go with the cloud resources and paying only for what I use, thereby reducing the costs and aligning better with the business growth here. So this topic is very general. It will be asked for 5 marks, guys. So make sure you write these points. And there are other points also. If you generally think also, if you have less space, so you can set up a office. You can set up a entire startup with just one room. So thereby, if you have lack of space, you can also come up. You can also opt for cloud computing. Thereby, it is also beneficial. There are not just this. There are multiple benefits of cloud computing, economics of cloud computing as to how you can save money, how you can make revenue from cloud computing. All those points could be covered under economics of cloud computing. Looking at the open challenges are, the first one we have is cloud definition. So cloud definition is very fluid. I might consider cloud as a storage entity. You might consider cloud as a storage entity. Along with that, there is security aspect also. Looking at the NIST definition, this is one definition which is most widely used. So it will tell the self-service, resource pooling, elasticity, measured service, and all of that. But then if you're looking at the David and this person's classification, it is slightly different. And if you're considering the UCSB's ontology approach, it is again different. So these people are trying to refine, to further refine the cloud computing's definition, cloud computing's structure. So all these definitions are evolving even now, and there is no fixed fixed definition as to cloud provided. This is one not that critical challenge, but then yeah, it is one challenge present. Next we have is the cloud interoperability and standards. First one we have is the vendor lock-in. So vendor lock-in remains a big obstacle for enterprises. So without standardization, these companies are at a risk of losing or unable to switch the cloud vendors easily. So thereby there could be conversation, there could be high conversion costs, and there is limited flexibility also. If you are using the legacy systems, it will be difficult for you to shift, right? So if you are using old Windows 7 software and you are trying to implement your cloud services there, it is again a little difficult. Then we have open virtualization format. So there are efforts which are being made to establish standards for cloud interoperability, like open visualization format for virtual machines, and initiatives are taken by the forums which are present. So the main goal here is to have the seamless migration between different cloud vendors and their ability to interact with each other over multiple platforms. The key solution to these problems could be by making use of the universal APIs. So these universal APIs will help us to work across different cloud services. Next we have is scalability and fault tolerance. So the cloud's ability to scale on demand is an advantage, but then it requires scalable cloud middleware that can handle large number of users and resources accordingly. So designing a system that can handle a huge traffic, along with that, when there is no traffic, it should shrink accordingly, right? So all these things are very complex challenges. Scalability is, yes, it is one of the complex challenge, and then fault tolerant is also very important, because cloud system should be able to withstand any failures without impacting the services which are happening in the front end. Services might be happening, but because of fault tolerance, the working should not stop there. So in order to enable that also, fault tolerance is also very important. Next we have security, trust and privacy. So security is one of the major threats, or one of the major challenges over the cloud platforms, right? So the increased use of virtualization technologies will create new security vulnerabilities, like data stored in the cloud may be safe from the unauthorized access, but then when it is processed in the memory, it could be exposed to the virtual machine manager or any other thing. Trust and privacy are again the concerns which will be happening, because you are storing your personal data on cloud, and there could be a third person who is trying to access your data. Yeah, all those things could happen, right? So there is a need for a legal and technical solution to address these problems, and it has to make sure that the cloud services will follow a strict rule, there is proper transparent accountability is happening. Then you have organizational aspects. So like we know that the businesses will manage the IT services, and they have to shift from the traditional to the cloud services. So one of the major challenge here is, how will the IT departments function when much of the infrastructure is shifted to cloud? So again, what is the role of IT department in organizations when they are highly relying on the cloud, and how will the compliance and regulatory frameworks adapt to the cloud environment, especially when the businesses lose the control over how the work is happening? All these are a threat or a challenge, right? Next we have is implications of for businesses. That is, moving the IT services to cloud will help us will introduce political, legal, operational considerations. So organizations may lose their control over some aspects which they had in the IT infrastructure, but then when you are shifting to cloud, it may not be there. So speaking of the broader implications, yes, it is available, but then the minute things which could be done in the infrastructure here cannot be done here. Thereby, it can impact the business also. So thereby, even this addressing this challenge is very important. So this is the end. We have covered all the important topics of third module. If you have any doubts, do let me know in the comments, and stay tuned. Fourth module will be updated pretty soon. Thank you.